Marco here from Riviero Live CS. Welcome back to the channel. Today we will continue reviewing engines and APU system. And again, I want to apologize for the delay. I've been extremely busy in the last month, but here we are. Thank you for the patience. And today we are going to finish talking about the engine system description, and then we'll talk about the APU. And we'll start with the engine ignition system. Each engine has two igniter plugs. The EEC arms the igniter plug selected by the ignition select switch. The left igniter receives power from the associated AC transfer bus. The right igniter plug receives power from the AC standby bus. And that's important to remember, guys. An auto relight capability is provided for flameout protection. Whenever the EEC detects an engine flameout, both igniters are activated. A flameout is detected when an uncommanded rapid decrease in N2 occurs, or N2 is below idle RPM. And we have two methods for starting an engine in flight. One is windmill, the other one is cross-bleed start. None of the ground start protection features are functional during in-flight start. Note, at low N2 values, the oil scavenge pump may not provide enough pressure to return oil to the tank, causing a low oil quantity indication. Normal oil quantities should be indicated after a start. If cross-bleed starting is required, the cross-bleed indication, XB for the compact engine display, is displayed above the N2 dial. This indication is based on airplane altitude, airspeed, and N2. During engine in-flight starts, the EGT start limit red line can be shown depending on the start logic as determined by the EEC. If only the EGT red line is shown, this is the in-flight start EGT limit. If both the EGT red line and the EGT start limit red line are shown, the start limit red line is the in-flight start EGT limit for all engine starts. Now, if we go to the thrust reverser system, it is for ground operations only and is used after touchdown to slow the airplane, reducing stopping distance and brake wear. Hydraulic pressure for the operation of engine number 1 and engine number 2 thrust reversers comes from hydraulic systems A and B. If hydraulic system A and or B fails, alternate operation for the affected thrust reverser is available through the standby hydraulic system. When the standby system is used, the affected thrust reverser deploys and retracts at a slower rate, and some thrust asymmetry can be anticipated. The thrust reverser can be deployed when either radio altimeter senses less than 10 feet altitude, or when the air-ground safety sensor is in the ground mode. When reverse thrust is selected, an electromechanical lock releases. The isolation valve opens and the thrust reverser control valve moves to the deployed position, allowing hydraulic pressure to unlock and deploy the reverser system. When either reverser sleeve moves from the stowed position, the amber reverse indication located on the upper display unit illuminates. So instead of green here, you will be an amber indication. As the thrust reverser reaches the deployed position, the reverse indication illuminates green and the reverse thrust lever can be raised to the tent number 2. This position provides adequate reverse thrust for normal operations. When necessary, the reverse thrust lever can be pulled beyond the tent number 2, providing maximum reverse thrust, which you can see here in this angle. The reverser light, located on the aft overhead panel, illuminates when the thrust reverser is commanded to stow and extinguishes 10 seconds later when the isolation valve closes. Anytime the reverser light illuminates for more than approximately 12 seconds, a malfunction has occurred, and the master caution and engine system annunciator lights illuminate. Note a pause in movement of the reverse thrust levers past the 10 number 1 toward the stow position may cause master caution and engine system annunciator lights to illuminate. A pause of approximately 16 seconds engages the electromechanical lock and prevents the thrust reverser sleeves from further movement. Cycling the thrust reversers may clear the fault and restore normal operation. And there is a warning here saying actuation of the thrust reversers on the ground without suitable precautions is dangerous to ground personnel. Okay, let's talk about the APU now. And here you can see a picture of where the APU is located in the Boeing 737 and some of the components. The auxiliary power unit, or APU, is a self-contained gas turbine engine installed within a fireproof compartment located in the tail of the airplane. The APU supplies bleed air for engine starting or air conditioning. An AC electrical generator on the APU provides an auxiliary AC power source. And here you can see how this air inlet door looks on the 737-800NG. APU operation. The APU starts and operates up to the airplane maximum certified altitude, which is 41,000 feet. The APU supplies bleed air for both air conditioning packs on the ground or one pack in flight. Both transfer buses can be powered on the ground or in flight. Fuel to start and operate the APU comes from the left side of the fuel manifold when the AC fuel pumps are operating. If the AC fuel pumps are not operating, fuel is suction fed from the number 1 tank. During APU operation, fuel is automatically heated to prevent icing. APU engine air routes to the APU through an automatically operated air inlet door located on the right side of the fuselage. And remember that picture we saw in the previous slide? That's the door. APU exhaust gases discharge overboard through an exhaust muffler. Air for APU cooling enters through a cooling air inlet above the APU exhaust outlet. So we can see it here. This air circulates through the APU compartment, passes through the oil cooler, and vents through the exhaust outlet, which is right here. Electrical requirements for APU operation. APU operation requires the following. APU fire switch on the overhead fire panel must be in. APU fire control handle on the APU ground control panel must be in. Battery switch must be on. Electrical power to start the APU comes from the number 1 transfer bus or the airplane battery. With AC power available, the starter generator uses AC power to start the APU. With no AC power, the starter generator uses battery power to start the APU. Moving the battery switch to off on the ground or in the air automatically shuts down the APU because of power loss to the electronic control unit. The automatic start sequence begins by moving the APU switch momentarily to a start. This initiates opening of the air inlet door. When the APU inlet door reaches the full open position, the start sequence begins. After the APU reaches the proper speed, ignition and fuel are provided. When the APU is ready to accept a bleed air or electrical load, the APU gen off bus light illuminates. Note, while the APU is starting using battery power only, The CPS frequency indication will be blank, and the AC volts indication will be 0 when the AC meter selector is set to APU gen. After the APU completes the start sequence and the blue APU gen off bus light illuminates, the CPS frequency will show actual APU frequency and AC volts will show actual voltage. During the APU start cycle, the APU EGT indication may fluctuate from 0 to 1100 degrees Celsius prior to normal EGT rise, and the low oil pressure light may cycle on and off several times. These indications have no adverse effect on starting the APU. It is not necessary to monitor EGT during start. If the APU does not reach the proper speed with the proper acceleration rate within the time limit of the starter, the start cycle automatically terminates. The start cycle may take as long as 120 seconds. Automatic shutdown occurs in the event of EGT exceedance. If the start fails or the APU gen off bus light fails to illuminate by the end of the start cycle, a system failure has occurred and the fault light illuminates. Operate APU for 2 full minutes before using it as a bleed air source. This 2 minutes stabilization is recommended to extend the service life of the APU. Now, if we talk about the shutdown of the APU, operate the APU for 1 full minute with no bleed air load prior to shutdown. This cooling period is recommended to extend the service life of the APU. When the APU switch is moved to off, this time delay is met automatically. Moving the APU switch to off trips the APU generator, closes the APU bleed air valve, and extinguishes the APU gen off bus light. Shutdown occurs automatically after 60 seconds. When the APU speed decreases sufficiently during shutdown, the fuel valve and inlet door close. If the fuel valve does not close, the fall light will illuminate after approximately 30 seconds. An immediate shutdown can be accomplished by pulling the APU fire switch. An electronic control unit monitors and controls the APU. Automatic shutdown protection is provided for overspeed conditions, low oil pressure, high oil temperature, APU fire, fuel control unit failure, EGT exceedance, and other system faults monitored by the ECU. The ECU automatically controls APU speed through the electronic fuel control. If speed or EGT exceed acceptable levels with the APU providing electrical load, only some electrical load is checked. When the electrical power load and air extraction raise the EGT above acceptable levels during engine starting, electrical load shedding occurs prior to reducing bleed air. When electrical load and air extraction raise the EGT above acceptable levels other than during engine starting, the inlet guide vanes move toward a closed position, reducing bleed air extraction while maintaining electrical load. Okay, APU automatic load shedding in flight. If the APU is the only source of electrical power, all galley buses and main buses are automatically shed. If electrical load still exceeds design limits, both IFE buses are also automatically shed. On the ground, the APU attempts to carry a full electrical load. If an overload condition is sensed, the APU checks galley buses and main buses until the load is within limits. Manual restoration of galley and main bus power can be attempted by moving the cabin utility power switch to off, then back on. All right, that's the end of the video for today. I hope you liked it. If you did, please give me a thumbs up. And if you are not subscribed to the channel yet, please do it now. If you think these videos could be useful for somebody else, please share them. And that's going to help me a lot to grow the channel. Even though I'm going to be busy for the next weeks, again, I will do my best to upload a video for next week. So hopefully we can do that, and we'll finish with the engines and APU system review. Until then, guys, please take care and hope to see you soon.